Hello everyone, in this video we're going to prove the given identity, and it looks like we're going to want to go from squares to the fourth power, so it'll be easier probably if we try to go from the left side to the right side. So let's go ahead and begin our proof by rewriting the left side. So we start with tan squared alpha plus 1 times tan squared alpha minus 1. Now whenever we see tangent squared and 1 in the same place, that should of course trigger one of the main three trigonometric identities which we refer to as the Pythagorean identities. So let's recall those, starting with sine squared theta plus cosine squared theta equals 1. Then we divided both sides of that by cosine squared to get tangent squared theta plus 1 equals secant squared theta. There's one also for cotangent squared, which we can obtain by dividing both sides of the original Pythagorean identity by sine squared, but we don't really need that here, so we'll just use this. We notice that the tangent squared theta plus 1 can be replaced with secant squared theta, so we get secant squared alpha times tangent squared alpha minus 1. From this identity, we notice that we can go ahead and take tangent squared and rewrite it as well. If we just take this identity and solve it for tangent squared theta, we end up with tangent squared theta equals secant squared theta minus 1. So if we go ahead and write this as secant squared alpha times secant squared alpha minus 1, then we also have this minus 1 that was already there, so we get another minus 1. So we end up with secant squared alpha times secant squared alpha minus 2. Keeping in mind where we're headed, we can see that once we distribute that, we should be home. So we end up with secant to the fourth alpha minus 2 secant squared alpha, which is precisely where we wanted to end up. And at this point, we are finished with our proof, and we can say QED. So that was basically an identity involving tangents and secants. That's why we utilized this second identity that we wrote up here quite heavily. And that should do it. So be safe until our next meeting.